The next topic is ionic radii or size of the lanthanoids. The size of the lanthanoids continuously decrease from lanthanum to the lutetium. The continuous decrease in the size of the lanthanoid from lanthanum to lutetium is due to the lanthanoid contraction. So there is a very small decrease in the size from lanthanum to lutetium. So we can say the size of all the lanthanoids is almost same or comparatively same. The size of the lanthanum is 1.69 angstrom, where the size of the lutetium is 1.44 angstrom. So for the 15 elements from lanthanum to lutetium, there is only 0.25 angstrom size is decrease, means less than 1 angstrom, or I can say less than the half angstrom the size is decrease for the 14 elements from lanthanum to lutetium. So this decrease in size is almost negligible. That's why we can say that the size of the lanthanoid is almost same. Now next is the lanthanoid contraction. The definition is the slow and steady decrease in the size of the 14 elements, or I can say the 15 elements from lanthanum to lutetium is called as lanthanoid contraction. What is the meaning of slow? Slow meaning is very small. Slow meaning is very small decrease in size. Steady means the continuous decrease in the size from lanthanum to lutetium. So very small and continuous decrease in the size of the 14 element after lanthanum, from lanthanum to lutetium is called as lanthanoid contraction. So the first element is lanthanum plus 3. After that there is cerium plus 3. Then praseodymium plus 3. Then neodymium plus 3. And in the middle of series there is a gadolinium plus 3. Then terbium plus 3. And in the last of the series, that is ytterbium plus 3, and finally there will be the lutetium plus 3. So we can say there is a regular decrease in the size of the lanthanoid metal ions. So there is a continuous decrease in the size. Next is, what is the cause of the lanthanoid contraction? Why the lanthanoid contractions occurs? It is because of the poor shielding effect of the electrons which are present in the 4f subshell in case of the lanthanoid. So lanthanoid contraction cause is the poor shielding effect of the 4f subshell electron present in the 4f subshells, or the electron present in the 4f subshells. The next one is the consequences of the lanthanoid contractions, means the effect of the lanthanoid contractions. Lanthanoid contraction having many consequences. The first one is, due to the lanthanoid contraction, the size of all the lanthanoid is almost same. As we know that from lanthanum to lutetium, there is only a decrease in size of 0.255 angstrom, which is very small, or I can say almost negligible. The second consequence is that because of the same size, it is difficult to separate the lanthanoid from each other. Third one is that because of the lanthanoid contraction, the size of 4D transition metals element become similar to the size of 5D series transition elements. This is the 3D series, this one is the 4D series, and this one is the 5D series. This is our 5D series. We know that as we move down the group, the size increases. So as compared to 3D series, the size of 4D series element is bigger. In the same way, the size of this 5D series element should be bigger as compared to size of the 4D series elements. But due to this lanthanoid contraction, the size of the 5D series elements is almost similar to the size of the 4D series element. Some elements like as zirconium and hafnium, niobium and tantalum, molybdenum and tungsten are having the same size in 4D and 5D series elements. And because of the lanthanoid contraction, the redox potential of all the lanthanoids also decrease continuously, and there will be a very small change in the redox potential, that is from minus 2.5 volt to minus 2.25 volt. And the fifth consequence is that lanthanum trihydroxide is more basic than lutetium trihydroxide. Any chemical substance which can release the OH negative ion is basic in nature, and because all the lanthanoids having 3 OH negative ions, so they are basic in nature. So according to Fazan rule, Smaller the size of cation, more will be the covalent character. And we know that as we from lanthanum plus 3 to lutetium plus 3, the size of cation decreases or size of the lanthanoid decreases. So lutetium trihydroxide having the smallest size, so it is the most covalent in nature. So if lutetium trihydroxide is covalent, so it will not dissociate easily to release OH negative ion, so it will become least basic. Lutetium having the highest covalent character, so lutetium trinitrate will be least stable towards the heat and it will decompose easily. So lutetium trinitrate are thermally least stable and it will decompose readily among the nitrates of the lanthanoids.